Hello students, today we're going to talk about graphing linear inequalities. Please don't forget to take notes as you go and complete the survey that follows at the end. If you have graphing paper, you might want to take that out now. However, you don't need it. You can do rough sketches of each of our equations that we put up. All right, a couple of things that you need to know. We need to decide, just like we had inequalities, we had open closed circle and we shaded to the left and to the right on the number line. We're going to have to do things like that as well. The first thing is deciding whether we're going to have a solid line or a dashed line. This is the same idea as doing the open circle versus closed circle. If we have a greater than or equal to or less than or equal to, we're going to draw a solid line, just like we did a closed circle. This means everything on the line is a solution to our linear inequality. However, if we have a greater than or we have a less than sign, that means we're going to be doing a dashed line just like we did the open circle. That means everything on the line is not a solution to our equations, or inequalities. And just like we shaded to the left to the right, we're going to be now shading above or below a line. So same idea. If we have ourselves a greater than or a greater than or equal to, we think about numbers that are bigger. We shade above the line. If we have a less than or a less than or equal to, then we think of numbers that are smaller. We're going to shade below the line. So let's look at a couple of examples. This first one here is negative 3x minus y is less than or equal to 0. The first thing we need to do is get it so it's in slope-intercept form. It makes it a lot easier for us to graph. So we need to move the 3x to the right-hand side. If it's negative over here, we're going to move it to the right by adding it to both sides so that they cancel out. Negative and positive 3 create 0, so it cancels out. 0 plus 3x on the right-hand side, though, is 3x. We're going to bring that negative down with the y. So now the next step is to get rid of that. So in order to do that, the opposite of doing negative 1 times y is to divide both sides by negative 1. But remember, when you divide an inequality by a negative, it flips it. So it went from a less than or equal to a greater than or equal to. Then from here, we are now ready to graph. So if you need to write out a rough sketch, have it so that it goes from negative 8 to positive 8 on your x and your y axis. If you need more time to graph it, hit pause and create your graph. So now we're going to go ahead and plot our points. The first one we always start with is our y-intercept. Since this doesn't have a number in the back, we always treat it like it says plus 0, which means our first point is going to be on the y-intercept, or the origin. So it says 0, 0. Then from here, we're going to go ahead and plot the other points. Since it is a whole number, we can put it over 1, and we can plot our points from there. What ends up happening is we plot 4 or 5 points, and we want to go from end to end on this. And now we need to decide if it's a solid or dotted line. Remember, if you see a line, you're going to draw a line. So right here, we know that we have a greater than or equal to, so we're going to draw a solid line. Again, remember, that means that all the points on that line are solutions. Now we need to decide, am I shading above or below? This is a greater than or equal to sign, so that means we're going to be shading above. If you're trying to figure out, well, why am I shading above? Really look at your y values. If we're looking at the y values that have to be greater than everything, all the numbers that are positive head upwards. So what I'm doing is I'm going to be shading in the area where it has all those positive y values opposed to all those negative ones. Let's take a look at another example. In this one here, we have x is less than negative 3. We've done problems like this with the equal signs, so we don't need to actually solve for anything or move anything around. We can go ahead and start graphing. Same exact graph, negative 8 to positive 8 on the x and the y axis. Remember, with the x ones where there's no y involved, we have a vertical line through that value. So our first point is going to be at negative 3, and then we can plot points above and below that exact line. Now we need to decide, is it a solid or dashed line? So once again, we're trying to find out from here if it's a solid or dashed. Since it's just less than, as we saw before, that means it's going to be a dashed line. So what I'm going to do is draw a dashed line, and again, that means that nothing on that line is actually a solution. Now I have to decide, am I shading above or below? Since it's a less than sign, that means I'm going to be shading below. But what does that mean with a vertical line? Well, for these, we're really going to be looking now at the x values. On the right side is a lot of positives. On the left-hand side, though, we have all our negatives. So all of our answers here are going to be the solutions to here on the left-hand side of this line. Let's take a look at another example. We have 2 more left to go. We have y is less than or equal to 5 halves x plus 5. It's already in slope-intercept form, so we can go ahead and start graphing it. Once again, negative 8 to positive 8 on the x and y axis. If at any time you need a moment to graph that, hit pause. So now we're going to start with our y-intercept, which is at positive 5. So my first point is going to be at the positive 5 on the y-axis. If we do our rise over run, 5 over 2, we would rise 5 and run 2. However, that would go off the graph. So we're going to go the exact opposite, which means we're going to go down 5 and to the left 2 to create our second point, and then repeating that process to get the third one. So keep in mind that this is a positive slope, so the line should rise from left to right. Again, looking at our values here, or at our inequality here, it's a less than or equal to, so I see a line, I draw a line. Again, that means all those answers, all the points that are on that line represent solutions. So now I have to decide above or below. Since the less than or equal to, I'm going to shade below the line. So once again, we're looking at our y values. Our y values have to be bigger or less than the 5 halves x plus 5. So we're looking at where all our negative y values are, which is down in this direction here. So this would be our solution, this entire shaded area and all the points that are on that line. One last example, y is greater than 5. Again, it's already in slope-intercept form, we just don't have a slope here. And again, remember, whenever we have the y's, that means we have a horizontal line. So essentially we're going to graph our y-intercept, which is at positive 5, and then we're going to create points that go to the left and to the right. Once again, we need to identify if it's going to be a solid or dotted line. Since it's a greater than, we don't have a line underneath. That means the solutions are not included. We do a dashed line. So as you see here, there's the gaps in between. And then once again, we're going to identify, is it going to be a shading above or below the line, and it's based on the fact that it's greater than. Greater than means we shade above. So once again here, where we have a y value, we're going to be looking at the y values. That means all the values above this line here are our solution. Everything within that shaded area is a solution. If you have any questions, please make sure you write them down and bring them to class tomorrow or enter them into the survey. Don't forget to complete the survey that follows the video. See you tomorrow.